Hi everyone, I'm Priya Angel G, Assistant Professor in the Department of Aeronautical Engineering at Gojan School of Business and Technology. Welcome to this presentation on monoplane and biplane configurations and the evolution of propulsion systems in aircraft. Let's see the content one by one. Introduction to aircraft wing designs. Aircraft wings have evolved in many ways. Monoplanes use a single main wing and are common in modern aviation. Biplanes have two wings stacked one above the other. These were widely used in early flight history. Features of biplane configuration. Biplanes have two wings, one above the other, held together by struts and wires. This design gave high lift at low speeds and worked well in tight spaces. However, it created more drag and limited speed and range. They were mainly used during World War I and in early aviation. Advantages of monoplane configuration. Monoplanes have one wing, reducing drag and allowing higher speeds. They are lighter and more efficient, ideal for both civil and military aircraft today. That's why almost all modern aircraft are monoplanes. Monoplane versus biplane, a quick comparison. Let's compare. Monoplanes have one wing, lower drag, and better speed, used in modern jets. Biplanes have two wings, more drag, and lower speed, used mostly in history and stunt flying. Design evolution over time. In early times, biplanes were made from wood and fabric. During World War I, they were used in combat and had better control. By the 1930s, monoplanes with metal bodies became more common. Over time, designs improved. Low-wing monoplanes came in the 1940s, swept wings in the 1950s, and composite material aircraft from the 1980s onward. Evolution of propulsion systems. Aircraft propulsion has also come a long way. It began with piston engines in the early 1900s, followed by jet engines in the 1940s, and now we're focusing on green and smart propulsion systems. Early piston engines and propellers. Piston engines powered early aircraft like the Wright Flyer. They used fuel combustion to turn propellers and were simple, light, and cost-effective. Even today, they are used in small planes for training and recreation. Jet propulsion breakthroughs. In the 1940s, jet engines changed aviation. Turbojets enabled high-speed and high-altitude flights, especially in military jets. Later, turbofan engines became popular in commercial aircraft because they were quieter and more fuel-efficient. This allowed faster, longer, and more comfortable flights. Modern engines and innovations. Today's engines are smarter and cleaner. High-bypass turbofans improve fuel use and reduce noise. Afterburning turbofans help military jets fly at supersonic speeds. Geared turbofans improve efficiency, and adaptive engines can switch modes for better performance in different flight conditions. Future propulsion technologies. The future is exciting. Electric propulsion offers zero-emission flights for short distances. Hybrid electric systems cut fuel use in bigger planes. Hydrogen engines release only water vapor. Scramjets and ramjets are for ultra-fast flights and space travel. Ion and plasma engines may even power drones and spacecraft in the future. Conclusion. The integration of design and propulsion. In summary, aircraft designs and propulsion systems have evolved together. From biplanes to sleek monoplanes, and from piston engines to clean energy systems, the journey reflects our push for faster, safer, and greener aviation. And the future holds even more possibilities. Thank you. Thank you for your attention. I'm Priya Angel G, Assistant Professor in Aeronautical Engineering. Feel free to reach out if you'd like to learn more or discuss this further.